All right, what's up, guys? Let's go ahead and take care of some math problems. We've got this situation here where they want us to solve for x given this triangle. All right, many of you guys would think about Pythagorean theorem. Because it is a right triangle, you are indeed correct. Next thing is labeling. Many people think it doesn't matter, but in general, I would say A is the smaller side, B is medium, and C is definitely the larger. So next we're going to substitute into A, B, and C. Appropriately, right? So we got 6, 9, and x. All right, so let's do the quick math here. Notice that A, B, and C are generic. X is the actual value they're using, so we'll do that. This gives us 17. From here, we've got to take the square root on both sides. Okay. Now, additionally, whenever you have a square root, you do look for those perfect squares embedded in the product. So let's go ahead and take out a 9. 9 times 13. Since we know the square root of 9 is 3, we get, all right, that takes care of number 1. Okay. All right. Next up, by the way, number 2, we're going to skip. We'll have you guys practice that in class. Let's go to number 3. And they want us to write this ratio in reduced form. So we have 12 to 3, which can be written with a colon, 12 to 3. And in these kinds of problems, you want to observe that they have, well, you look for something in common. We observe that they have a 3 in common, which is 3 times 4, and 3 times 1. Okay. Get rid of what they have in common, and we're left with a 4-to-1 ratio. Okay. All these are equivalent. This is reduced form. Okay, let's look at number 4. You got A plus B. Number 4A plus 4B. Okay, they want it simplified. Anything they have in common, take out. If you stare at this long enough, you'll realize that you can't do much on top, but you do have a 4 in common, so let's factor that out. You'll see this expression equals this one, so let's quantify that. And anything times 1 is itself. So at this moment, we can cancel out, right? A plus B divided by A plus B will cancel. And we're left with 1/4. Okay. All right, that takes care of that. Okay. So next up, we'll get some practice in class. Going to move on to this next problem. It wants us to write an expression in simplest form for area for this expression, right? The area of a circle, area of a triangle. So Where do we start? We're going to start with what we know, like always, right? So we're going to have to start with the area. Oops. Area of a circle, which equals pi r squared, and the area of a triangle, which equals base times height over 2. Okay. So again, we're trying to get started, but we know we're going to have to deal with these. So we have the formulas. The question is, where do we go from there? All right. So the easy one would probably be the area of the triangle. Okay. So that's our first step. Is area of a triangle equal we need to plug in base and height, so this is the base, this is the height. So we get square root of 4 over 2. I know you guys can do it in your head, but it's important to know you can multiply both values under the radical, which is 2 over 2, which equals 1. Okay. So there's our area. Excuse me. So the next thing we do is we're going to need the circle, right? The area of the circle, which requires the radius, but we don't have the radius. But we do have this bad boy. Go blue. Okay. We're going to need this guy, which is for the triangle, it's the hypotenuse. Okay. And for the circle, it's the diameter. Okay. So let's go ahead and come up with this value. So let's see here. So we're gonna, again, we need this guy. So there's different methods. We're gonna go a squared plus b squared. Okay, or we can say it's diameter. Okay. So a squared plus b squared equals c squared. So we have square root of 2, square root of 2 equals to the diameter squared. 2 plus 2 equals d squared. We have 4 equals d squared. And we have 2 equals d. So the diameter is 2. So therefore, half of that would be 1 for r. Okay? So let's go and use that information. 1 is r. So now we go to a step 3. And that is all we needed for the area of the circle. So area, oops, the circle is pi r squared, which equals pi 1 squared, since r is 1, And 1 squared is 1. And 1 times pi is pi. Okay, so we're pretty much done, except we got to look back, and it wanted us to express this in simplest form. So area of a circle or area of a triangle. Go back to black. And the area of a circle over area of a triangle. Area of a circle is pi. Area of a triangle is 1. So we get pi. Okay. All right. Next up is this bad boy down here. Okay, so we have absolute value of x minus 10 equals 6, solve for x. So the worrisome part is this guy, so let's get rid of this guy from the set of the equation. Okay. Now this side, this becomes x equals 16 or negative x equals 16. And if we divide by negative 1, then you have x equals negative 16. Okay, so the solutions are x equals 16 and negative 16, or x equals plus or minus 16. All right. Guess we'll get some practice there. And next, are O, N, and P collinear, right? Collinear on the same line. If so, name the line on which they lie. O, N, and P, are they all on the same line? Kind of tricky, but no. Next. So the main thing on that one is vocabulary, right? Collinear. And 8, we have if EF equals 2x minus 12, FG equals 3x minus 15, and EG equals 23. Find the value of X, EF, and FG. The drawing is not to scale. All right. So 2x minus 12, 3x minus 15, EG is 23. Okay. So I guess this plus this should equal to 23, right? This plus this equals 23. Right. So we would say EF plus FG equals AG. All right. It's going to combine like terms. 2x, 3x is 5x. This and this combined is minus 27 equals 23. Oops. So let's go ahead and add 27. So we get 5x equals 50, x equals 10, and they wanted what? X, EF, and FG. Okay, so x is 10. Right, there's this part, and this part is EF. Which is 8, and they wanted FG, which is 15. Okay, and those two combined are 23. All right, done and done. Let's see here. All right, I guess we can make this the last one. Judging by appearance, name an acute angle, an obtuse angle, and right angle. Okay. So let's get creative here, and we'll call this acute angle would be over, excuse me, we'll start off with acute, right? Less than 90. We can say is who's definite less than 90. It's like x's. Then obtuse is over 90 degrees. So we can say W, that's for sure. And then a right angle. Right, that's in case it's close, we put that little square, indicate it's 90 degrees. And this would definitely be, who else? Just Y. Okay. Or rather, we can say just in general, angle X was acute, angle W was obtuse, and angle Y was right. All right, guys, appreciate your time. Have a good one.